My name is Alena, and I am the student presenter for Science on a Sphere at the MSU Museum. Today, we're going to be continuing our virtual program series by talking about life deep down in the ocean. This is related to our in-person Life Without Sunlight show. So once again, the app that we're using for this program is the SOS Explorer app. So on your Apple or Android device, open the App Store and search for SOS Explorer, and you can download that. All right. So we're actually going to start off our presentation with the SOS Explorer app. So the world is made up of tectonic plates that are always moving, and they're creating new land, creating new mountain ranges in some places, and in some places the seafloor or the crust of the earth is just kind of going back down into the earth. So it's kind of like it's shrinking. So basically all over the earth we have lots of cool things going on where tectonic plates collide. So let's open our SOS Explorer app. And it's pretty easy to find the data set that we're going to use for today. So it's the age of the seafloor data set right here, the third one down. So this doesn't tell us what's happening at each of the plate boundaries, but you can see the age of the seafloor. So the red is the newest, and purple and blue are the oldest. So on places like the west coast of North America, you're getting new seafloor appearing because of the movement of the tectonic plates. It's older on this side of the Pacific plate with the blue. And then again, you have all this red going on in here, kind of a tectonic mess in this area. And then some new seafloor popping up here around the edges of Antarctica. Yeah, so you just look at that for a little bit. So today we're going to be looking at what happens on these areas where these tectonic plates are colliding. The black lines here, whether they're blue or red. So as the plates move apart on one edge or get stretched thin in the middle, spots can open up, and magma, which is called lava when it reaches the surface, can bubble up from deep inside the earth. Above the surface, this can create volcanoes like on the left here. But below the surface, it looks a little bit different. An example is on the right here. So just a lot of bubbles, a lot of sulfur, and some yellow in there. It's a cloud, but within the water. So deep sea vents form along the edges of tectonic plates or in their spreading centers. So it's in the middle of the crust, is kind of spreading out and gets thin in the center. Seawater infiltrates into the Earth's crust, and then it warms because of contact or just the existence of hot magma. So you can see here, the blue arrows are the cold water percolating down, and then it warms up. And then once it warms up, it flows back up and exits the crust, bringing nutrients and minerals from the crust with it. Now the water can reach 700 degrees Fahrenheit. It's super, super hot. Water boils at 212 degrees Fahrenheit or 100 degrees Celsius. The water above the sea vent shimmers or can create a black or a white smoker depending on what's coming out of the vent. And if the water was in the air, it would have evaporated, but since we're down here, deep in the bottom of the ocean, due to extreme pressure, it doesn't evaporate. It just stays in the water and creates these plumes. So in 1977, a small submarine named Alvin discovered the first deep sea vent, deep sea hydrothermal vent near the Galapagos Islands off the coast, the western coast of South America, almost 3 miles below the surface. This is also the first year that we had a complete map of the seafloor with all its trenches and mountains. So here is a map of all the known sea vents all over the world. Let's see. A lot around the edges where we saw those tectonic plates, collisions happening around this island region. Yeah. So sadly, we don't have access to this data set on the SOS Mobile Explorer app, but if you'd like to learn more or look at it more closely, you can go to the NOAA Science on a Sphere website and look up the deep sea vent locations data set. So these are all the ones we know about. You can see that they're mostly located around where the tectonic plate boundaries are, but because we saw that the age of the seafloor is so young, there's always going to be new ones popping up that we don't know about yet. So to show you what these vents look like, let's do a demonstration. So we're going to need a tall, clear container full of cold water, very cold, like the same sort of water that you would find at the bottom of the ocean, where it isn't warmed up by the sunlight, and then a small bottle filled with hot water and a few drops of food coloring. So this is the same sort of water that you would see coming out of a hydrothermal vent. So we're going to lower the bottle full of hot water into the container of cold water. Think about what you expect to happen. So you're going to blow up, explode, nothing's going to happen. We're asleep. All right, so let's do this. And drop it in. There you go. So this bottle is blue, so it's not super obvious, but it is filled with blue water as well. So it starts off kind of slow. There we go. There's the plume. So the hot water is coming out of the top of the bottle and dispersing. It's the same way that the hot water comes out of the vents and mixes with the cold water around it, bringing dissolved metals, minerals, and other chemicals up into the seawater. If you see with this, the blue food coloring, it goes up to the top here, the surface, because hot water rises to the surface of cold water, and then it kind of just filters back down. So more of this container of cold water is mixing with the hot water, so that hot water is becoming warm water, and then it's also spreading all those nutrients, or in this case, the blue food coloring, around. Right, so we just let that sit for a little bit. Yeah, kind of just collects up there and then it spreads down. So let's see what it looks like at the end here. A little bit further down. So it's mostly blue, you can see here. We have blue all the way back down here. It started here, went up, and then it's just kind of spreading out. So again, that's what happens with the hydrothermal vents. So the scientists weren't looking for anything deep. When they're looking for deep sea vents, they weren't expecting to find a lot of things living around them. But when they did find the vents, they were surprised by the diversity of life that they encountered. So remember that without the life from submarines that would allow us to see what life looks like down there, the organisms in the deep ocean live in complete darkness. No sunlight reaches them. So many unique organisms have adapted to survive in the deep ocean surrounding these vents. This includes microorganisms like archaea and bacteria, which convert chemicals expelled by the vents into energy. Got some bacteria there. So they don't use sunlight as energy like plants do on the surface. Similar organisms are also found in areas like the hot springs in Yellowstone. Since most life on Earth depends on sunlight, like I said, I have a short video that introduces how organisms survive deep in the ocean.
The majority of life on the planet is based in a food chain which revolves around sunlight. But of course, in the deep sea, there is no light. Once you go below 200 meters, light just disappears. That means there are no plants down in the deep ocean. So there is a food chain that operates completely independently. Instead of having sunlight being used as the primary form of energy, chemical energy is used. And that is from these chemical-rich fluids such as methane and also hydrogen sulfide that leak out of the seafloor from fissures that have been formed by tectonic activity. And instead of there being plants, there are bacteria which act as the primary producers, and they utilize this chemical energy in a process known as chemosynthesis rather than photosynthesis, which is pretty amazing.
So basically, instead of depending on plants which use sunlight, this whole ecosystem depends on bacteria which convert chemicals that are expelled by the hydrothermal vents as the base of their food chain. All right. So in 2011, scientists returned to the Galapagos Rift hydrothermal vent sites where they first discovered the hydrothermal vents. and captured a video of the life they found there. So there are going to be special crabs, shrimp, and these huge 3-foot-long Riftia tube worms with red tops. So look for those. Galapagos rift, right here. All right. You can see the Riftia worms in the center there. A few other things on the rocks, maybe like a lobster or a crab over on the right. This is a video of what they saw deep down there. So these are those Riftia worms. They kind of take in nutrients. They kind of breathe through those red tops. You can see the water is shimmering here. They can pull those red tops into themselves. Got some cool snails on the rocks here. So you can see there's actually a lot of stuff living, and you can see the water is shimmering from that really, really hot water. Let's see. Yes. Yeah, crabs even way down here. So you can also see that a lot of these things don't have a lot of the organisms don't have a lot of color to them. It's because they mostly don't need it. They're down here where it's pitch black, so they can't see color anyways. What are we zooming into? Ah, we need some shrimp. Some shrimp have adapted to live here. Yeah. And again, back to those Riftia worms. They're huge. They're about 3 meters long. I think about 1 meter long. They're about as long as your arm. Yeah. Get some crabs in there. We'll come back to the Riftia worms later. All right. So another hydrothermal vent that we can talk about is in the Mid-Cayman Rise. So it's in the Caribbean on a plate boundary, kind of a trench area. So the hydrothermal activity was found there in 2011, same year as they went back to the Galapagos vent site. Here they found lots and lots of shrimp that survived due to the bacteria. They don't live right on the vents, but a little further away where the hot water has mixed with the cold to create a zone where the temperature is a nice toasty 140 degrees Fahrenheit. So it's hot, but not too hot. So it's hotter than we could survive it up here, but it's colder than boiling. So you can see there's a lot of shrimp down here. It's not just a bunch of rocks. All right. Let's look at one last vent location. This is in the Mariana Back Arc. It was discovered in 2016. So that's over here. Ooh. Again, there's a little boundary here. So this area is called the Ring of Fire. There's a lot of volcanic activity along the boundaries of these plates, including hydrothermal vent activity. All right, so I have a short video again that shows the life, including the snails that they found when they discovered the hydrothermal vent.
We're sitting in the crater of a volcano that the people who proposed this dive thought, well, they said there's no known historic eruptions of this thing, but we've been finding hydrothermal activity.
Oh yeah, there's one right there. Yeah, they're all over the place. Wow.
Oh boy, look at the snails.
Oh, is that pretty?
There are shrimp. A couple, I see their little feelers. The little reddish
Polychaetes?
thing. You know, I was wondering.
Polynoid polychaetes.
Yeah.
Holy cow. Look at that.
All right, so you can see in that video that that was less than 4 years ago, about 4 years ago, and they just discovered that, and the scientists were still excited to be seeing things they still didn't expect to see. So life at each vent we've seen is different, and it's surprising. If you think back again to the age of the seafloor dataset, new seafloor is being created every day. New life is developing. We have all these different super cool organisms that are living here. There are probably thousands of vents and species of organisms that we don't know anything about yet. The deep ocean really is the last frontier for exploration. The last part of our program today is a super easy activity where we can create our own Riftia tube worms. The Riftia worms are up here in our top left corner. Yeah. Alrighty. So to create your own tube worm, all you need is a paper straw or plastic, a feather from a craft store, maybe not from a bird, and then a pipe cleaner. And then markers are optional. So step 1 is to wrap the pipe cleaner tightly around the base of the feather, just to make sure they're connected. Step 2, slide the pipe cleaner non-feather end first into one end of the straw, and make sure that the feather can also go into the tube here. And then step 3 is optional. You can decorate the straw with a marker however you want. We have some unique life down there. This is kind of what your final product should look like. Okay, so compare your worm to a real Riftia worm. Notice that you can pull the feather into the straw like the Riftia worm can shrink into itself. This is a diagram of the giant tube worm, one of those Riftia worms. You can see up here with the feather, we've got this, their kind of feeding, breathing area where they capture all those nutrients that are in the water because of the hydrothermal vent. They have a symbiotic relationship with the bacteria that live on the hydrothermal vents. There's the tube they can retract inside of. You can see they live in these colonies too, so you can make a bunch of Riftia worms and make your own Riftia worm colony. Alrighty, so that is all we have for the program today. As always, if you can, please think about supporting MSU Museum's educational programs. We are providing these for free, but they aren't free to make. The link is here, and then it should be posted in the comments wherever you're watching this video. Thanks to NOAA for creating the Science on a Sphere exhibit and the app and all these cool data sets and information. And then to the MSU Federal Credit Union for supporting our in-person Science on a Sphere exhibit. I hope you enjoyed the program and have a good rest of your day.